Hello everyone. On this video we will be going over equivalent fractions. Okay, so first let's look at what exactly is an equivalent fraction. Equivalent fractions are fractions that share the same value. Okay, so for example, think about money. Okay, let's say money and the fraction 1/2. Okay, so if you have 1/2. So if you think about it, 50 cents is half of $1. Okay, I don't think anybody would argue that. So that means that 1/2 is equal to 50 cents out of 100 cents. Okay, think about this also. Let's say 25 cents is half of 50 cents. Okay, again, I don't think anybody would argue that. So that means 1/2 is the same as 25 being half of 50 cents. Okay, so let's look at it with a picture. Okay, if you're still a little bit lost. So let's say if we have, I'm not going to make a perfect circle, but I'll do my best. Make that a little bit better. Okay, so we're just going to assume these are all perfect circles. That was okay. Okay, so if we have 3 perfect circles, and let's say with those 3 perfect circles, we're going to cut them right in half. Okay, so we're going to shade in half of these quote-unquote perfect circles. Okay, so we have 3 circles that half of them are shaded in. Okay, so this is the visual explanation. Okay, so let's look at the first circle. Okay, so you have one shaded section over 2 total sections. So it's 1/2. Okay, so let's look at this one. We're not going to shade any more of this, but what we're going to do is we're going to increase the number of sections. We're not shading anymore. Okay, so let's just draw a line right across. Okay, it's still the same half, but now you have 2 sections shaded in out of 4 total sections. You see how these are basically the same, but just written a little bit different? This is still half, this is still half, just written a little different. Let's say with this one, okay, so let's say if we get this one, and we draw a line across, but we also draw one through here, and we draw one through there. Okay, so right now we have 1, 2, 3, 4 shaded sections out of a total of 8 sections. Okay, so what does this tell us? Well, this tells us that 1/2 is the same as 2/4, which is the same as 4/8. And if you wanted to keep going, that would be the same as 8/16. Would be the same as 16/32, and it can keep going and going and going. These are all equivalent fractions because we can get this 1/2 and we can cut that in half, and then we can cut it some more and cut it some more and cut it some more, and it can keep going and going and going and going, and we can make that total number of pieces as high as we want to. Okay, just so happens we stopped here at 8, but we can make it as high as we want to, and it would still be the exact same value as that 1/2. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and take a look at creating a factor tree or prime factorization, because that's going to be very useful in creating our equivalent fractions. All right, so let's see your factor tree, which is also known as prime factorization. All right, so what I'll do is I'll give you an example of how to create the quote-unquote factor tree. Okay, so let's say if we factor 12 using prime factorization. Or in this case, the factor tree. Okay, so what we're going to do when we do that is we're going to start off with our 12, and we're going to break that down into factors until we can't break down the individual factor anymore. Okay, and I'll show you what I mean by that. Okay, so what we're going to do, I'm going to do this twice, and I'll show you why in a second. Okay, so 12, we know that 12 can be 4 times 3. Okay, so let's say 4 times 3. Now the 3, we can't break that down anymore. The only thing you can make it is 1 times 3, and that wouldn't make any sense. So we're just going to leave that as 3, and we're going to circle that. Now that 4, you can factor that down to 2 times 2. So you have 2 times 2. Now the 2, you can't factor that down anymore except 2 times 1, and that really is unnecessary. Same with this 2, you can only make it 2 times 1. So if we get all of our circled values that we can't factor anymore, what does that tell us? That tells us that 12 is equal to 2 times 2 times 3. And this is your prime factorization. You just reduce 12 to the product of a bunch of prime numbers. Numbers that can't be reduced anymore. Okay, so why do I have this second 12 up here? I have this second 12 up here because what if instead of 4 times 3, you decide to break this down to 6 times 2? Okay, so 2 times 6 or 6 times 2 doesn't matter. Okay, so the 2, you can't break that down anymore except 2 times 1, and we don't need to do that, so we go ahead and circle that 2. But that 6, you can make that 2 times 3. Now this 2, you can't break that down anymore, so we're going to go ahead and circle that. The 3, you can't break that down anymore, so we're going to go ahead and circle that. So what do we have here? We have that 12 is equal to 2 times 2 times 3. Okay, so it doesn't matter what 2 values you start with. You can start with 4 times 3 or 2 times 6. With prime factorization, you will always end up with the same thing. That's the cool thing about it. Okay, there's no one path to it. Whether you take the left path or the right path, you'll still end up at the same place. All right, so let's say, for example, you wanted to factor 18 using prime factorization. Okay, and what I want you to do is go ahead and press pause and try to solve that one on your own, just using the steps above. All right, so I'm assuming that you've gone ahead and you've solved this one. Let's go ahead and verify your answers. Okay, so I'm going to go ahead and do this one twice just to see which way you started. Okay, so for this one, 18, we're going to break that down to 6 times 3. Okay, this 3, we can't do anything else with that one. That can't be factored anymore, so we go ahead and circle it. The 6, that can be factored to 2 times 3. The 2 can't be factored anymore. The 3 can't be factored anymore, so we go ahead and circle them. So we have our 18 equals 2 times 3 times 3. Now, what if you decided to, instead of 6 times 3, you go 9 times 2, which is still 18. Same thing. The 2 can't factor that anymore, so that stays the same. And the 9 becomes 3 times 3. And 3 can't be factored anymore, so you go ahead and circle those. So you have 18 equals 2 times 3 times 3. Okay, so as you see, you end up right at the same place, no matter where you start from. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to actually creating equivalent fractions. All right, so for example, if we wanted to complete the equivalent fractions. All right, so for problem A, let's say you have 7/8 equals some unknown value over 16. We want to find that unknown value. Let's say for problem B, we have 4 is equal to some unknown value over 16. Okay, so let's say for problem C, we have 2 and 5/6 equals some unknown value over 12. And let's say for problem D, we have 3/4 equals some unknown value over 16. All right, so I'm going to show you step by step how to solve each one of those. Okay, so we'll start with problem A. Okay, so the first thing you want to do, you want to factor the denominator with the unknown. So this is your unknown. You're going to factor this denominator so that you have at least one of your factors match this one. Factor the denominator with the unknown numerator. Okay, now you don't have to factor it completely, and I'll show you what I mean by that. So we know that 16 is equal to 8 times 2. All right, we're going to leave it like that because it matches this one. We have an 8 here, we have an 8 here. So that means your 7 over 8 is equal to some unknown, and instead of 16, we're going to write it as 8 times 2. Okay. Now the thing is, we want both of those denominators to match. Okay. So we have an 8 here and we have an 8 here. So we're good there. The only thing missing is a 2. So we need a 2 in the denominator over here. Okay, so your second step, multiply the numerator and denominator by any missing factors of the unknown. Denominator. Okay, so we have our unknown denominator, well, unknown numerator here, but that denominator. Okay, so since we're missing a 2 over here, I'm just going to rewrite it. 7 over 8 is equal to something over 8 times 2. So we have to multiply this times 2 to get these to match. So we multiply this by 2 over 2. Okay, so what does that give us? Well, that gives us 2 times 7 over 2 times 8 equals some unknown over 8 times 2. Okay, so all we did was multiply this 2 and this 7 and this 2 and this 8. So now our denominators match. So you have 2 times 7, which is 14. Oh, sorry about that. I'm jumping ahead in my mind. Over 2 times 8, which is 16. Just some unknown over 16. Okay, so in order for this to be true, this is 16 and this is 16. That means this has got to be 14. Because if this is anything other than 14, these two will not be equal. Okay, so that means that 7 over 8 is equal to 14 over 16. All right, so let's go ahead to problem B. And let's do the same thing. We have 4 is equal to some unknown over 16. All right, so when you have a whole number and you're trying to find the equivalent fraction, you rewrite it. Because remember, 4 is the same as 4 divided by 1, which is equal to some unknown over 16. So this is the one we're going to use instead of this one. Okay. So here we have our 16. Okay, so for our first step, 16, just to make sure we have a 1 here, it's just 16 times 1. That's what we're going to do here. So we have one of our factors matches our other denominator. Okay, so now we have our second step. we have 4 over 1. Oh, let me give that a little more room. Let me move that over a little for a second step. 4 over 1 equals some unknown over 16. Well, 16 times 1. Okay, so here both sides have a 1 in the denominator. What's missing? The 16. So we go ahead and we just multiply. I'm going to go ahead and move that up. And as you get a little more practice in, some of these steps you'll wind up just skipping. You'll develop your own, pace. You'll get a little bit faster. This is just a step-by-step breakdown. After you do a couple of them, you'll get a lot faster. But I want you to see the concept behind it first before you jump into automatically doing the quicker way. Okay, so we have our 4 over 1, something over 16 times 1, but we're going to multiply the numerator and denominator by 16. Okay, and if you want to do it, you can multiply the numerator and denominator using this method, or you can use this method, same thing. Okay, so 16 times 4 is 64. So this gives us 64 over 16 is equal to some unknown over 16. So the only way this can be true is if your unknown is equal to 64. So that tells us that 4 is equal to 64 over 16. All right. So we're going to continue this on the next page. If you're still writing, feel free to press pause. But we're going to go ahead and move on to problem C. So we're going to continue. So problem C, say 2 and 5, 6. All right, so there are a few ways if you want to solve this one, but probably the easiest is just convert your mixed number into an improper fraction. Okay, so convert to an improper fraction. Oops. Okay, now to convert this to an improper fraction, you have 6 times 2, which is 12, plus 5, which is 17. So I have 17 over 6 is equal to some unknown over 12. Okay, and just like before, we factor the denominator of our unknown so that at least one of those factors matches this side. Okay, so that means we have 12 is equal to 2 times 6. Okay, so if we rewrite that, 17 over 6 is equal to some unknown over 2 times 6. All right, so this side has a 6 in the denominator, this side has a 6. So the only thing missing is the 2. Okay, so that means we have to multiply this side by 2 over 2. So we have 2 times 17 over 2 times 6 equals some unknown over 2 times 6. So now our denominators match. So 2 times 17 is 34 over 2 times 6, which is 12. which is equal to some unknown over 12. And the only way this can be true is if your unknown is equal to 34. So that means 2 5/6 is equivalent to 34 over 12. All right, so go ahead and do problem D. We have 3/4 is equal to some unknown over 16. So what I want you to do is go ahead and press pause and try to find that equivalent fraction on your own. All right, so I'm assuming you've pressed pause and you've worked this one out. So let's go ahead and verify your answer. Okay, so we have our 16 here. So we have 16 is equal to 4 times 4. So we want one of our factors to match that. Okay, so you have 3/4 is equal to some unknown over 4 times 4. Okay, so you have a 4 here and a 4 here. You could pick either one of those. So that means we're just missing one of those 4s. So that means on this side, we have to multiply the numerator and denominator by 4. So you have 4 times 3 over 4 times 4 equals some unknown over 4 times 4. Where both of our denominators now match. Okay, so you have 4 times 3, which is 12, over 4 times 4, which is 16, is equal to some unknown over 4 times 4, which is 16. And again, the only way this can be true is if your unknown is equal to 12. So that means you have 3 over 4 is equal to 12 over 16. All right, so that is how you would find your equivalent fractions. All right, so hopefully this made sense, and I'll see you on the next video.